Hey, welcome back. Today's lesson is 11.9, reciprocal trig functions. All right, so up until now, we've really been talking about three trigonometric functions, which are sine, cosine, and tangent. But some of these also can be flipped around, and we can talk about reciprocal functions. So their definitions are shown below. All right, so what we're talking about are the other three trig functions are secant, cosecant, and cotangent. Now, cotangent's the easiest one because cotangent basically tells me that the cotangent is equal to 1 over the tangent. So that one's easy to remember. Secant and cosecant are kind of opposite of what we think. Like I remember that secant is 1 over the cosine and cosecant is 1 over the sine. So it's kind of opposite of what you think it is. All right, so let's keep that in mind as we go on to exercise number 1. So you might want to make a note of that before we go on. All right, really. So find a way to remember this because again, this has to be put into that file cabinet in your brain and make sure you remember it. Exercise 1 says, considering your work with sine and cosine, evaluate each of the following and express your answers in exact and simplest form. So if they're talking about exact and simplest form, we know that we are talking about using our special angles. So what I like to do first is go to kind of the top or on top of where we are and say, well, I know I have 60 here. So let's think about what 30 degrees is and what that point is, what 60 degrees is and what that point is. And the other one is 45 degrees. I don't know if we know that, if we need that, but we'll put that one in too. So remember, it's cosine comma sine, cosine comma sine. And what do I always tell you to remember? I tell you to always remember that the sine of 30 is a half. All right, so I know that the other value that it toggles with is radical 3 over 2. And in 60 degrees, they're going to flip-flop. So the cosine is going to be 1/2, and the sine is going to be radical 3 over 2. And for 45 degrees, that's the easiest one to remember because they're both rad 2 over 2. So secant of 60 degrees. So I know the secant of 60 degrees is 1 over the cosine of 60 degrees. And I know that the cosine of 60 degrees is cosine 1/2. So 1 over 1/2. If that's confusing to you, put it in your calculator. But basically what you're doing is stay, change, and flip. So this is equal to the number 2. Okay, moving on to cotangent of 150. Now, if you remember the cotangent, and I'm wondering if I discussed this, if it's here. Oh, here it is. I did forget to talk about it. If you look right here, we know that the tangent of an angle is equal to the sine of that angle over the cosine of that angle. So the cotangent of that angle is equal to just flip it, reciprocal. All right, so cosine over sine. So now we can move back to our problem here to cosine 150, cotangent 150. So I know that the cotangent of 150 is equal to 1 over the tangent doesn't help me, but the cosine of the angle, let's put the 150 in so we don't get confused. Cosine of 150 over sine 150. Now remember here, we also need a reference angle because 150 is not in my first quadrant. 150 is in the second quadrant. In the second quadrant, I have negative and positive. Remember how I do that? I take so I know this is positive, positive. I know this is negative because I go this way and then up. So this is going to be negative, positive, negative, negative, and positive, negative. So that helps me find my sine and my cosine for each one of my quadrants. And what is the reference angle? Well, I know the reference angle is going to be 180 minus 150. So my reference angle is 30 degrees. So, oh, we have our angles up here. Okay, so 30 degrees. So we also know, we know that the cosine of 150 over sine 150 is the same thing. Cosine is negative. The cosine of my reference angle over the sine, because I know sine is positive, of my reference angle. And the cosine of 30 degrees is radical 3 over 2. And I know my sine of 30 degrees is a half. Again, if you need to put this into your calculator, you can, but the 2's will cancel, and we're simply going to be left with rad 3. So the cotangent of 150 degrees is equal to rad 3. So cosecant, 3 pi over 4. Now, if you're not good working in radians, then convert. That's what one of the last lessons were. So if I convert, I know that pi is equal to 180. So 3 times 180 divided by 4 is equal to 135 degrees. So I'm asking for the cosecant of 3 pi over 4, which is equal to the sine of 3 pi over 4, or the sine of 135 degrees. Now, just like we talked about, I know that 135 degrees is in the second quadrant. I know the second quadrant is negative positive. So my sine here is going to stay positive, which is a good thing. So the sine of 135 is the same thing. I'm sorry, it's 1 over. You caught that. I know you did, because it's a reciprocal function. So it's 1 over the sine of our reference angle, and our reference angle is going to be 180 minus 135, which is 45. So we did need that 45 degrees. So 1 over the sine of 45 degrees, which is 1 over rad 2 over 2, which is equal to 2 divided by rad 2, which we can rationalize by multiplying the top and bottom by rad 2 over rad 2, and you get 2 rad 2 over 2. These cancel. You're left with radical 2. Lots of simplifying there. Just like we never have a 0 in the denominator because it makes a function undefined. It also, you should never have a radical in the denominator. So if you need to pause, rewind, do it now before we move on to exercise 2. Which of the following is closest to the value of the secant of 52 degrees? Now, the beautiful thing about this one is this is all about the calculator. So secant of 52 degrees. So let's pull up that calculator. So here we are, and the beautiful thing is right underneath the control button, you'll see the word trig. All right, ooh, it's going a little nuts. So it's asking for the secant of 52 degrees. So secant, whoops, let's see if we can get that to go away. Secant of, delete, of 52 degrees. Now I should make sure I'm in degree mode, but let's see if I get the right answer, and I don't, because I know that's definitely not the right answer. All right, so I'm going to make sure I'm in degree mode, so hold on one second. Yep, I am in radians, so I'm going to change that to degrees. Okay, now I can go back to my home screen, the screen I was on. So now I'm going to do secant, trig, there it goes again, secant. Why are you making this difficult for me? 52 degrees. And I get still the wrong answer. I just changed it to degrees. All right, hold on one second. Okay, so that time it worked. I got my 1.62427, which is the answer to number 2. So glad that I set this thing up ahead of time, and the calculator still does not work well on this smartboard. So for that, I apologize wasting some of your time. So that was supposed to be a really quick and easy question, and it turned out to be a little bit of a disaster. So it's all about the calculator on that one, pretty easy. So because each of these reciprocal trig functions has a variable denominator, there are angles in which these denominators can be zero, okay, and hence the function's undefined. So which of the following values of x is not in the domain of cosecant x? Now, because the answer choices are all in degrees, we can do what we just did, but I'm afraid it would take me like another half an hour to do it on that calculator. So instead of doing it on the calculator, because we can use our brains instead of our fingers, we can say that we know that the cosecant of x is equal to 1 over the sine of x. So what I'm saying is, where is the sine of x equal to 0? Because that is where I'm going to get my denominators. So you know that you're going to get zeros on your quadrant angles. So if you consider your quadrant angles, again, I always start here, 1, 0. So and then I move here, negative 0, negative 1, 0. This is 0, 1, and hence this has to be 0, negative 1. So my sine is my y value. So I know I'm going to have sine of x equals 0 at 0, or 360, and 180. So here it is right here, 180. And I can double check that in my calculator, but I'm not going to, because I don't want to grow old before I finish this lesson. All right, so because we talked about this one, because each of the functions is dependent on sine or cosine, it is possible to determine the sign, whether it's positive or negative, of each based on the quadrant of the input angle. All right, so for an exercise 4, it says determine the sign of each of the following. So cotangent of b, or beta, all right, if beta is in quadrant 2, I know quadrant 2, remember, this is how I do it. Quadrant 2 is negative, positive, so I know it's negative, positive. All right, and I know the cotangent is going to be the cosine of beta over the sine of beta, which is going to be a negative over a positive, which yields a negative. For the secant of beta, quadrant 4, so let's see, here we are in quadrant 4. Quadrant 4 is positive, negative. So I know this one is positive, negative. And the secant is 1 over the cosine of beta, which is going to be 1 is positive. All right, and the cosine in this case, which is my x value, is positive. So this is going to give me a positive value. And the last one says quadrant 3. So in quadrant 3 is negative, negative, right? So we have negative, negative. And if they're asking for the cosecant, already I can tell it's going to be negative because it's 1 over the sine of beta, which is 1 is positive. The sine of beta is negative. So this is going to yield a negative solution. All right, so going on to exercise 5. I think we're going to be able to use what we know now. If the cotangent of theta is less than 0, so what does this mean? It means that the cosine of theta over the sine of theta is negative, right? That's what less than 0 means. I kind of translated it. It makes it easier for me. And if the secant is greater than 0, that means the cosine is greater than 0, okay? Because it's 1 over the cosine. Then theta could be in which of the following angles. Well, let's see what I know. I know that my cosine is positive. That's given to me. And what do I know about the sine? Well, I know that cosine right here, I know that cosine over sine is negative, which means my sine has to be negative. So in order to get a positive negative, it means I'm going positive this way and then negative this way, so I'm in the 4th quadrant. So which one of these angles are in the 4th quadrant? All right, I know that only this one is, right? This is in the 1st quadrant. This one is the 2nd quadrant. This is the 3rd quadrant between 180 and 270, and there's my answer. Okay, so exercise 6. If alpha is an angle whose terminal ray lies in the fourth quadrant, stop. I just stop right there. So already I'm saying fourth quadrant, positive, negative. I know I'm down here. So alpha is an angle, terminal ray lies in the fourth quadrant. And I know that the cosine of A is equal to 1/3. All right, so cosine of alpha is 1/3. Then determine the exact value of the cosecant of alpha. Show how you arrived at your answer. So they want us to find the cosecant of alpha. And I know the cosecant of alpha is 1 over the sine of alpha. And what do they give us? They tell us the cosine of alpha is 1/3. All right. So how do I find the sine given the cosine? Well, I can use my identity. I remember my identity says cosine squared theta plus sine squared theta is equal to 1. All right, so if I let x equal sine theta, I can say cosine squared theta is 1/3 squared plus x squared is equal to 1, and you just solve this. So I get 1/9, right? When you square the numerator, you square the denominator, plus x squared is equal to 1, minus 1/9. Use your calculator if the fractions are flipping you out, and you get x squared is equal to 8 over 9. And then you take the square root of both sides, and x is equal to the square root of 8 over the square root of 9 is 3. Now remember, that's sine x, sine theta, or sine of alpha. So I know that the sine of alpha is equal to, what did we say? It was radical 8 over 3. But beware, what is my sine of my sine? No pun intended. What is the sine of my sine in the fourth quadrant? It is negative. So make sure you're adding a negative out here. And then it's not asking us for the sine of theta, it's asking us for the cosecant. So I know that the cosecant of alpha is equal to the reciprocal. So it's -3 over rad 8. Now again, remember what I told you? If you left it that way, you actually would lose a point because you can't have a radical in the denominator. So there is some reducing to do. So let's bring it down here. 3 over rad 8 is equal to, let's see, instead of that, to rationalize it, we multiply the numerator and the bottom, the numerator and the denominator by rad 8 over rad 8. So rad 8 times rad 8 is simply 8, and we get 3 rad 8 up here. But remember, rad 8 we can reduce one more time to 3 rad 4 rad 2 over 8, and we still have a negative sign here, let's not forget about that, which is equal to 3 times 2 rad 2 over 8, which is 6 rad 2 over 8, and one more time reducing, I can reduce by 2, and I can get 3 rad 2 over 4. So this is equal to -3 rad 2 over 4. So seriously, don't forget the negatives. Seriously, I think that the hardest part of that problem was actually simplifying that radical. Okay, are we feeling good? I hope so, because I think that's the end of it. We are going to move on to our lesson tomorrow. So I kept it under 20 minutes. Sorry, I wanted to really keep it under 17 or 18, but that calculator really kind of messed me up today. But until tomorrow, make good choices, be safe. See you next time.